Good day, everyone. I want to welcome you to another lecture, and the lecture is on pointers and functions. Pointers and function. We've talked about pointers before. We said a pointer is a variable that holds an address of another variable. We said if a pointer variable is holding the address of another variable, the pointer is simply referencing or pointing to that variable. So with the indirection operator, you can send or get value from that variable a pointer is pointing to. And we said, how can a pointer be linked to um, an, another variable? We discussed that we have to use what we call the address operator or the ampersand sign with the variable name to get the address of a particular variable. And in the last class, we talked about functions. We said for us to be organized and for our program to be readable, we have to make our program to be in submodules called functions. And that this function will accept parameters, process or work on those parameters and return a value back to the called function. And I said in the last class that a function can only return a single data variable or a single data item. That in our course of programming, we will be faced with situation where we would like to return more than one parameter to the calling function. And in that case, we would need to use a technique called call by reference technique. We said for a function to return value back to the calling function, we need to use the keyword return followed by the variable or the value it wants to return. And we simply state that when a function is returning, it's simply passing value back to the calling function and also exiting the program. It means exiting the function. It means that a function, when it is called, is being called, the function is born. When the function finish executing, the function needs to die. So if we never return value, it means the value operated upon by the function or the result of the operation carried out by function is going to be destroyed. It will not be saved. So for us to return more than one data item, we need to employ the call by reference technique. So let's move on. So pointers and function, call by reference. So call by reference simply means we are passing variables address to a function. We're passing variables address to a function. So in a call by reference, the address of the data variable is passed to a function, the address. The address is copied into a pointer variable that belongs to the called function. The call function accesses the calling function variable via the indirection operator and pointer. The address of a variable can be thought of as a reference to the variable. We said for a variable, when a variable is created, a variable will simply have a data type which is used to create it, a variable name, a variable will have a value, a variable will also have an address, a location in the computer memory where the variable resides. We said it is hard for us dealing with address. It is cumbersome cramming address, but it is easier using the variable name. Just like in our everyday life, when we go to the web, it's easier remembering facebook.com than remembering the IP address of Facebook. So that's why we are giving user-friendly names, right? So the address of a variable can be thought of as a reference to that variable, a particular reference, a position where you can actually get the variable. So this technique makes the calling function variable available to the called function, and the called function does not have its own local copy of the variable. We said there's a technique we discussed in the last class called call by value, where a function is being called and a value of the calling function is passed to the function. But here in the call by value, a duplicate of the calling function's variable or value is passed. There's a duplication. But for call by reference, the address of the calling function variable is passed to the called function. So the called function does not have a copy of the calling function. So just like this, the example I love giving, if you actually have a huge data you want to send to your friends, or let's say a music video, and the video is about 10 gig, it will not be wise sending 10 gig maybe via the internet to each of your friends. So what do? You simply copy the video into a particular repository and you ask your friend to go there via the link, the address where the video lies. So what you do is you pass the address or the link of that video to your friends and they go there to what? So your friend will not have a local copy of the video. Depending on the permission, your friend can edit or just copy. It can be a read only permission or a read write permission. So what we're saying is with the address, your friend having the address can actually access and tweak and change the value of the reference variable of the video. So likewise, the calling function variable is available to the call function, and the call function does not have its own local copy of the variable. So if a called function must return several data items to a calling function, the programmer can use the call by reference technique. The calling function simply passes the address of its variable to the called function, which then writes data directly to the calling function's variable. Okay, another example. If you want to transfer funds to your friend living in, let's say, Canada, you have a physical copy, you have the cash, the physical cash with you. Due to restriction, let's say immigration laws and policy, you might not be able to carry the huge cash down to Canada. Well, you can actually ask or request your friend to send in the bank account. The account can be thought of as the address. So right from here in Nigeria, you can send or wire money directly to the account. So what am I trying to say here? Or what cue are we trying to get from this analogy? Like I stated in the last class, that the scope of a variable is limited. The scope of a variable is limited to the function where it is created. So we have what we call the local variable, whose scope is just within the function it's created. And we talked about the global variable that is created outside of functions. So everyone can access the global variable. But what about the local variable? The local variable with scope is limited. But with the concept of having an address, you can break limits, you can break the scope of that local variable. As long as you have the address of that variable, you can get and you can set value via the pointer variable. So let's look at this example. Calculate this cylinder volume program. So we want to use a get cylinder dimension function to ask the user to enter or to input the value for radius and height. So because we want to use a function to get the value for radius and height, we will not be able to use the return statement. Why? Because the return statement can only return a particular value. So we are going to employ the use of call by reference technique, which simply states we are going to pass the address of the radius and height to a pointer, will simply help us to transfer value directly to the calling function radius and height. So let's look at this example. So looking at this example right here, we can see that we have a variable pi declared with the data type double, and it's made a constant. That is to say, the value of pi will not be able to change. And we can see that pi variable is declared outside all functions before the main function. So it means that pi is a what? Is a global variable, global. So every function can access this variable pi. So the next in line is we have two prototype, function prototype. The void get cylinder dimension and calc cylinder volume. So prototype simply let the compiler be aware that there's a function that exists. The function does not have, like this get cylinder dimension, the function does not have a return type, and the function's name is get cylinder dimensions. The functions will receive address as argument, that the local variable of the function is a pointer. Also, we have another function prototype, calc cylinder volume. That's the name of the function. The function returns a value of the type float. The arguments passed or the local variable belonging to this function are of the type float. So let's look at the main function. We are able to declare three variables, radius, height, and volume, all of the type float. So it means radius is of the type float, height is of the type float. Also, the volume is of the type float. Now, we are calling the get cylinder dimension. We don't want to impute the value of radius and height in the main function. We want a particular function to take care of the radius and height. So we created the get cylinder dimension. So what are we doing? We are passing the address. You can see ampersand, the address of radius to this function and the address of height to the get cylinder dimension. So what happens at this line of code is that this address is passed directly to what? To the get cylinder dimension function header, and the height address is passed to the pointer here. You can see. So it is more like we are declaring floats, asterisk r underscore ptr equals the address of what? Address of radius. So address of radius. Likewise, h underscore ptr will be equal to the address of height. So these two pointers, they are both holding the address of radius and height respectively of the calling function. So from here, you can simply pass parameter of value to this radius and to this height. So looking at this function body now, we declare a local variable r and h. We simply ask the user to input the radius and the height of the function using the scene, and the value is passed to where the pointer is pointing to. Where is the pointer pointing to? It's pointing to this radius. So simply, this radius is having the value of r passed here, and this is having the value of the height. So the height is having a particular value now. So we can see that we can return more than one variable to the calling function. Now, since we are not using the keyword return now, we are not using the keyword return, you can see that the return data type is what? Is void. Now, here we employ what we call the call by reference technique. Well, here we are employing call by value. We are sending the value. So now, with this, the value have been passed to radius and the value have been passed to height. So with that, now, since radius and height have a value, we can now pass it into this function. What we're doing here is call by value. So any value, let's say this is 5 and let's say this is 6. So we are passing into this function. It comes here and the value of rad here is 5 and the value of height here is 6. So we can simply say pi, which is a global variable. Yes, we can access it. It's a global variable. It's now 3.14159.265 times 5 times 5 times 6. So after doing that, it will return the value back. It will return the value back here. So just imagine the value, the whole function here is replaced by the value this function returns. So volume equals what? Let's say volume equals 60. Then we can come here and say cout the calc volume equals 60. I think you understand now. So what are we trying to demonstrate in this context is we are able to pass in the address of the variables we want to pass in. We pass it into a pointer variable, and using the pointer property, we are able to send value back to these variables. So let's move on. So we can see that when we call this get dimension, get cylinder dimension, we are passing the address. So just imagine the address. Okay, just imagine the address of this variable is xff18 xff114, right? They differ by 4 because float is 4 bytes, right? So in the main function, let's say we created radius, height, and volume, and we said this is how they are declared. Please don't take this address for it. When you run yours on the computer, you have different address. So when you create these variables, let's assume this is what the address in the computer memory. These are the address reserved for it. So what we're doing here is we're now passing the address. So what's the address for radius ff18? We're passing it to this pointer variable. So this pointer variable is having the address of what? Radius, while the float asterisk h_ptl, this pointer variable is having the address of height. So here we're having ff14, ff14, right? So now you can see that in this function, it creates its own variable. Now we are able to create the local variable r and h, which that are here. And also this pointer variable belongs to this function. But now the content of this pointer is the address of the radius which we pass to it. So we can see the address of the radius, the address of this. So the address of radius and height are passed to the function and are stored in the pointer variable. Very easy. So now here in the function, we simply ask the function to input the radius and the height. So it is stored in this local variable. So assuming the user enters 10 for radius and 15 for height, so it is stored in this location, right? So what happened? Using the pointer, what we're actually saying is the value of R should be sent to where the pointer is pointing to. The value of R should be sent. What's the value of R? 10. So we are sending it to where the pointer is pointing to, which is what this radius. So this radius now have the value of 10. So the value of R is assigned to where R underscore PTR is pointing to. So the radius value is written there. All right. So likewise, with this statement, we are returning or we're passing the value of 15 to where the pointer is pointing to. So where is it pointing to? It's pointing at this address, and where's the address here? So with this now, we are able to what? We are able to pass in value to the function, to this function. So here now, this radius and height now have a value. We can now do call by value to get the volume. Okay, so after this, I'm going to do a class demonstration, and let's see what's okay. So let's continue. Let's continue with a class. So let me share the second screen with you. Okay, so looking at this screen right now, let's look at this as so. Let me share this with you. So write a complete C++ program that has a main function, a get2numbers function, and find big one function. So we are having three functions: the main function, yes, get2numbers function, and find big one. So the main function calls get2number function, which asks the users for two integers. So with the get2number function, we are asking the user for what? Two integer values, right? So that is the task of the main function. So in the prototype, I already have get2numbers function and find big one function, and I simply wrote this, right? So we will see how we will construct it. So in this get2numbers function, we can say, okay, since they are of the type integer, I can come here and say int first number. I can just say first number, comma, second number. First number, second number. So So I can simply copy this same value here, right? Okay. So these two variables belong to what? To this function. They belong to this function. So this is what I'll do. So because this function is just asking for two numbers, so I will just employ the use of a pointers int story. So you can come here. Why is it giving me an error? Let's see. I know the reason. So let's come here, get two numbers function. Let's paste it here and say okay. First, let me say first underscore PTR and second underscore PTR, right? Okay, so I can come here and say cout impute to integer values. Let me just to integer values. Okay, so I can come here and end the line. Okay, so come here and saying first number first. Okay, first number. Okay, second number, right? First number, second number, and can come here and say, okay, the pointer f underscore okay equals where the second where the so the second number, yes, so should be saved where. Now you can see that we've not called our function, right? So we can come here and say, okay, let's call this function get what? Two numbers, then go for intelligence. So what do we pass? We pass the address of what? First number, the address of what? Second number. Now, I want you to know that this second number belongs to the main function. It does not belong to the get two numbers function. So we have first number here. This first and second number belongs to this function. So it's just like in Nigeria, you can be bearing a, and someone in United States can also be bearing a someone. So it doesn't mean you're the same, right? So you can do it this way. So it means I'm passing the address of this first number and second number to this function. Yes, the address will come here. So it means this pointer is pointing to this, to the address of this variable. This second pointer s underscore ptr is pointing here. So via the indirection operator, this indirection, I can pass in value to the first, value to the second number. You can see. So I'm not returning anything. The data type here is void, right? So wonderful, wonderful. So the beautiful thing about programming is you can debug as you go. You can debug as you go. So it will flash, and let's see the results. It's compiling. So place inputs two numbers. So let me say 50 and 10. You can see. So it's not giving us any error. So it means that function works correctly, right? But we've not done or performed the second task. So then the function send the two integer to find big one, function, which simply returns the larger value. So it means if we call this function and it returns the larger value, we should be able to know, we should be able to save it, the larger value somewhere, right? So we can do it in this way. We can do it in two ways. Okay, so let's call find big one. So now first norm and second norm as values now, right? So we can pass in the value, call by value, second norm, yes, because they both have values. Now, do you understand? So they both have value. Okay, now we have to be consistent. We have to be consistent. So if this function is returning a value, where are we going to save the value? We've already said the function will save the value here. So let's just create another variable. So bigger number. Let's say bigger number. So we can come here and say, okay, the bigger number, bigger norm is this, right? So now one of the errors here is too many arguments in the function call. Yes, why? It's not consistent. It's in this function header line, there's no argument. Here also there's something wrong. So we have to be consistent. So we come here and input integer y, because what we're passing are both integer. So I can come here and say int a, comma, int b. Let me say int b, right? So it will not complain anymore. We have to be consistent, right? So so this big one, now from the function call, we are passing first norm and second norm. So what are we doing? The value of first norm will be saved in A, the value of second norm will be saved in B. So we can now make our decision. If A is greater than what? Than B, right? What do? We can say, let me use this word, return A. Right? We can say return A, or else it depends, because we can have more than two cases. A is greater than B, A is less than B, and A is equal to B, right? So we can come here, or else if, let me make it, else if A is less than B. So if A is less than B, what's the bigger number? Return what? return B, right? Else, you can just return else, return just one. Let's just say A, right? So if they are equal, you just return one. Now, what I'm doing here is because this condition, the, if it is true, we are only having a single evaluation, right? But if it is more than one, you can just put it in bracket this way and place this return A here. So we can put it here. Okay, do, right? So if it is more than one statement, it will evaluate. So else if A or if B is this, else, right? If else statement. So return B. So what would it, because it's returning an integer, right? You can see that the return type is integer as well. So we can come here and display the results. We can also use a function, but display the result. New line. The bigger number, oh sorry, the bigger number, let's say between first norm, let me give it a tab spacing, first norm and second norm, right? Okay, I can give it a space or a tab. Is what? The bigger number, right? So is the bigger number. So we can simply end our line, end line. Good. So let's see if we fulfill the task. So write a complete simple that has three functions. Yes. So the main function calls the get to number function, which asks the user for two numbers. Yes. Is able to ask the user for two numbers. Yes. And return them to the main. We've done that. Also, then the program send these two numbers to find the big one. So it send it to this function, yes, to now find the big one. How do we know it's the big one? If A is greater than B, return A that A is bigger, else if return B, else if they are the same, just return one, A or B, right? So the decision now will be saved in bigger number, and we're saying, okay, display the bigger number between the first number, we give it its star spacing. The first number, let me put, and the second number is, we give it its star spacing, is this. So it remains for us to return to incorporate a loop. So let's run to see if our code will run. Let's see. So we should input two numbers, 19 and 2, 19, press enter, 2, press enter. So we can see what happened, that our console did not wait. Okay, so we will do something we can do. We will incorporate what we call system pulse, or we can press Ctrl F5 to run. So 19 and 2. So you can see the bigger number between 19 and 2. So there should be a space between and 2 is 19. Okay, so let me put a tab spacing also. So Ctrl F15. Or if you're not doing it that way, you can come here and type system pause. You pause the system. You ask the system to be paused. Okay, so you can come here. Okay, so two values 19 and 55. So which is the bigger number? The bigger number between 19 and 55 is 55. Wow, that's good. Now you can see if we want to run this code every time, more than one time to confirm that it's working perfectly, we need to click on the local debugger to debug it every time. So what if we want to incorporate a loop so that we don't need to be asking the user. We will just ask the user when to exit when it's true. So we can come here and create a variable called can say loop, and we set the value of loop to, let's say, yes. Okay, so okay, so from there we can actually come and say, okay, use the while statement. While loop is equal. Now when we are making decision, what do? While loop is equal to what? To y, which stands for yes. Or because sometimes you can press the small letter y, or you see someone press the big capital letter Y, it's still Y. So you can say while loop equals capital letter Y, right? Let this happen. Let this happen. Let this happen. Right? So you can now ask the user after displaying cout, you can ask the user cout, do you want to perform this operation again? Do you want to perform this operation again? The question mark. Okay. Y for yes. Y equals yes. Any other key. Any other key for no. So no. So no is any other key. Any other key. So any other key, so you can come to a new line. So scene loop. So let's see if we've been able to incorporate our loop. So as long as the loop, it's y, it would keep asking this, it will keep performing this function. So let's see what it will give us. So input two values, let's say 23 and 55. So the bigger number between 23 and 55 is 55. Do you want to perform this operation again? Yes. So it exits. Press any key, input the value 55 and 100. Okay, the value, the bigger number is this. Okay, press any key to continue. Input, let's say 100 and 100. So it returns. So any other key that you want to perform. So let me press any other key. Press. So you can see it's exits. So so let me see. There should be a function called clear screen. Clear. Not too sure. Clear screen. Clear. So if you want to clear the screen, there's another function for that in which you can incorporate, and it will help you clear the screen, give you a new screen. So you can see we've been able to write this code to solve this particular problem. All right. So I want you to practice, keep practicing, keep practicing, keep practicing. You'll definitely get it. All right. So bye.